Hello, ladies and gentlemen, and welcome back to the 2002 Fermat paper. We're up to question number 20. In the diagram, YQZC is a rectangle with YC equal to 8 and CZ equal to 15. Equilateral triangles ABC and PQR, each with side length 9, are positioned as shown with R and B on sides YQ and CZ respectively. The length of AP is... Okay. So, I'm going to copy this diagram into our notebook as I make a few observations. Okay, notice that they don't have the 9 added in anywhere on their diagram. That's something we're going to have to do. And I wonder why they left the 9 out. Usually they add in lengths like that. There might not be a reason, but maybe there is a reason. Oh, I forgot there's a big triangle at the top. I'll have to draw this a little lower. So always a good idea to redraw your diagram. Okay, so PQR and YQZC. Here's B, here's A. And what do we want? We want AP isn't a length that we already have. It's just the distance that this triangle at the top has been translated from the bottom, that sort of thing. And let's add in our lengths. So we know we've got 9s everywhere. We got 15 here, we have an 8 and an 8. 15 overall here, and 9s here. Because of these 9s, we can actually work out what BZ is going to be. It's going to be, well, we got 9 here, we still have to make 15. So what do we need to add to 9 to get 15? 6. And a 6 here as well. Okay. So how are we going to get AP? Well, one thing that you could do, and I wouldn't be surprised if some of you out there were tempted to do this, would be to add some coordinates onto the system. No reason not to. We could call C the origin, so 0, 0. You probably know enough about equilateral triangles to get coordinates at A. And if C is 0, 0, then Q is going to be 15, 8. And you could probably figure out the coordinates of P and then use the distance formula there. So that's definitely one way that's going to work. But I think a slicker way that you might be able to see is so the distance from A to P. I mean, there's no real way of attacking that directly. But if we realize that it's the same as the distance from B to Q, and if we really wanted to, also the same distance as C to R. But as soon as I add in the B to Q length, suddenly this makes a lot more sense. Look at what we've got. We've got a right angle triangle, a 6, and an 8. And if you're trying question number 20 on the Fermat, you should probably be able to already tell me what this other length is. It's part of a Pythagorean triple. You're going to get a 10 right here. Okay? So you can either know that that's the Pythagorean triple, or you can realize that AP, as we've already said, is BQ, and BQ squared is going to be 6 squared plus 8 squared. It's by Pythagoras. That's going to be 36 plus 64. It's going to be 100. So BQ is square root of 100. Definitely 10. So AP, the length that we're trying to work out, is 10. So you can try to do it coordinate-wise. That's I think, what a lot of people's instincts would be. But if you take a step back, and as I remarked at the start, ABC and PQR, they're the same rectangle. Or sorry, they're the same equilateral triangle. They're just translated a bit. And once you make that translation connection, you realize A to P, which is a really weird length to work out, is the same as B to Q, which makes a nice, tasty right angle triangle right there. So hopefully this has all been good progress, and 10 is one of our answers. And there it is waiting for us at the very start, A, 10. That's going to be our answer to 20. All right. So in the next video, we're going to start Part C of this contest. And that'll be question number 21, Part C. Of course, the correct answers are worth 8. So this is where a lot of the points get made. And this is the area that separates the men from the boys, as they say. Or the women from the girls. Ladies from the girls, maybe. I don't know. I haven't heard that expression used on the female gender. But if somebody wants to, leave a comment to what the proper female version of separating from the men from the boys is. Because I'd really like to know. But we'll take a look at question number 21 in the next video. So I'll see you there.